Good evening, everyone, and a warm welcome to our event tonight. This is part of the Living Well with ALS webinar series, proudly presented by ALS United Greater Chicago. We are truly grateful for your time and presence this evening. For those of you joining us for the first time, our quarterly webinars are designed to provide practical guidance and valuable insights for individuals and families affected by ALS. Your participation means a lot as we work together to support and inform our community. Tonight's session is titled Navigating Genetic Insights and Testing. This program offers a comprehensive look at the genetic aspects of ALS. It begins with an introduction to ALS, detailing its nature, prevalence, and demographics. The program then delves into the basics of genetics, explaining genes, DNA, and heredity, and discusses common ALS-associated mutations. Before we get started and introduce our speaker, here are a few housekeeping notes. All participants will be muted during the session to ensure a smooth experience without background noise. If you have any questions during the presentation, please use the Q&A tab located at the bottom right on your screen. We will address as many as possible at the end of the program. If we are unable to answer all your questions within the allotted time, don't worry, we will follow up with responses via email. Finally, tonight's session is being recorded. Registered participants will receive an email notification when the recording becomes available. Thank you for your attention. Now let's proceed with the session. We are delighted to welcome tonight's presenter, Tara Jones. Tara is a genetic counselor specializing in neuromuscular disease and dementia at Cedars-Sinai. She has a deep commitment to families impacted by FTD and ALS, offering her support to at-risk family members of her patients. With her background in dementia care and personal experience with family members affected by the disease, Tara brings a wealth of knowledge and a unique ability to connect with patients facing both cognitive and physical challenges. We sincerely appreciate your time and insight tonight. Tara, the floor is now yours, and we look forward to learning from your valuable expertise.
Great. Thank you so much, Jomana. And I'm really excited to be presenting to the Greater Chicago region. I actually attended my genetic counseling graduate program at Northwestern in Chicago. So pretty awesome to get to present to you from the West Coast today. Really hoping that you guys kind of take away one or two things that you learned new today. And hopefully I am not going to be boring you with too many details that you were already aware of. All right, so let's go ahead and get started. I want to just add that I do hold shares for a genetic testing company called Myriad. They actually don't offer any genetic testing for neurologic diseases, so just a potentially perceived conflict of interest there. And Jomana did kind of go over our outline for today. Here it is in written form. We'll kind of start with talking about ALS, go into basics of genetics, and then combine the two. I will touch on the role of a genetic counselor. I'm aware that some of you may have already seen one and others may have had genetic testing via other means, such as through your neurologist without ever meeting a genetic counselor. And then we'll kind of do a little play on how to understand your own genetic results, and we'll finish off with some hopeful pieces on some new gene therapy that's available for the second most common familial cause of ALS. Oh, all right, so what is ALS? We'll try to kind of go over this briefly. Kind of starting microscopically, what's going on in the brain and spinal cord with ALS. It does affect this glutamate neurotransmitter system, which I'll show in another photo. But I want to highlight first what we see in the neuron. So there's thousands of different types of neurons in the central nervous system. We actually haven't fully identified all of them, but when we're talking about ALS, we're talking about the motor neurons. And in this particular picture, we have a signal that's kind of coming from a brain of a neuron out of the photo, and it's traveling down, meeting the synapse and going through this postsynaptic neuron. So that's kind of how the message is transmitting. And we're going to zoom in really close into the synapse. All right, so again, presynaptic neuron, this is a dendrite at the very end. We've got the glutamate that's transporting outside of the dendrite through a vesicle. And we have these receptors that hit the postsynaptic neuron. That's right on this edge that help transport the glutamate. And these receptors are important for making sure that there's a correct amount of glutamate between those motor neurons so that they can communicate appropriately. And as we know with ALS, the effect of kind of disrupting this transmitter system is that the motor neurons actually start to die. So looking at things on a clinical level, these are things that you might experience if you have ALS. There are also things that neurologists might uncover during an exam. So when we're talking about upper motor neuron, that's this kind of green line here. And the lower motor neurons are the ones that exit the spinal cord and innervate the muscle. So upper motor neuron signs might be spasticity, it might be bradykinesia. So spasticity is stiffness, bradykinesia is slowness. You might have brisk reflexes where you kind of become a little hyper-reflexive when you are tested with the hammer-looking device by a neurologist. And you might have spastic dysarthria, which might be kind of distorted speech. Whereas the lower motor neuron signs can be the fasciculations or twitches, muscle wasting, muscle weakness, and a flaccid dysarthria. So that could be kind of the very slurred speech. And I kind of highlight in the title that ALS is usually both upper and lower motor neurons that are affected. But diagnostic criteria has been changing. So ALS-Scorial criteria was later revised, but it created kind of these diagnostic certainties of ALS that would be suspected, possible, probable to definite. And more recently, the Gold Coast criteria came out where they were mentioning that these possible and probable cases, it was rare for it to eventually turn into a definite diagnosis of ALS. And it was leading to some uncertainty in families. And also the big issue here is it was preventing access to clinical trials. Because as many of you are aware, a lot of clinical trials say that you must have had symptoms for no more than 2 years, but some people take over a year to get diagnosed. And so the Gold Coast criteria tried to lower this threshold, and they basically say, if anyone has a lower motor neuron or upper motor plus upper motor neuron signs in at least one region, let's go ahead and call it ALS. It's got to be progressive. It's got to, we have to be certain that there's not any alternative explanations for those symptoms. Or you can have lower motor neuron in at least 2 regions. And then even more recently, the Miami framework came out that was proposing calling ALS part of a neurodegenerative spectrum. And we're actually trying to capture disease even before clinical signs show up. That's called that clinically silent stage. Prodromal stage is where they wouldn't meet a diagnosis of ALS, but they're showing some subtle signs or features that look like we're heading in that direction, and then clinically manifest is full-blown ALS diagnosis. So these are some efforts to try to increase access to clinical trials so that we can really move drug research forward. Also with ALS, they have kind of subdivided it into different kind of main groups. So if we look at the neuron level, classic is both that upper and lower motor neuron disease, whereas primary lateral sclerosis, or PLS, is just upper motor neuron. On the other hand, progressive muscular atrophy, or PMA, is just lower motor neuron. And it's important to note for these two types of motor neuron disease, eventually they may come to a diagnosis of ALS. So that's why your neurologist tends to follow you very closely for at least the first 2 to 3 years to make sure that the opposite neurons don't start getting affected as well. And then we further subdivide these main types into where the body region was first affected. So you might have bulbar ALS, where your dysphagia, the difficulty swallowing, and dysarthria are kind of the presenting signs, or it could be limb onset. And if it's just arms or just legs that are happening on both sides, then you might get flail arm or flail leg ALS definitions. And respiratory onset is where the capacity of the lungs is affected very early on in disease. So we've talked about kind of what's happening in ALS, what the signs are, what the diagnostic criteria are, gone into subtypes, but how common is it? So you may have heard that it's more common in males, and that is true. If you think of a group of 436 females, you might have one person affected with ALS. But if you look at 347 males, you might have one person affected. And age of onset is about between 50 and 70 years. But we tend to have a younger onset in those individuals who have family history. That's not always the case. We can have very late onset familial ALS, very young onset sporadic ALS. And then how common is ALS across the world? So we're looking at these prevalence estimates, and 7.96, 7.85, those are present in Japan and Italy. So ALS seems to be more prevalent, and there's more people with disease in those 2 countries. The one that's the lowest is here in China. It's important to note the methodology for getting these country estimates. Meta-analysis is a gold standard, but you can see for Canada and for the USA, it's actually based off of the National ALS Registry. So the authors of this paper really took that registry as being very accurate. But you can see that it's present all over the world, and We also have to keep in mind that some people might not have access to prompt diagnosis. So it might actually be a lot more prevalent in other countries than we realize. All right, so now that we've touched on ALS, we'll go into basics of genetics. So central dogma, DNA to RNA to protein. Believe it or not, this is the simplest image I've been able to find showing this process. But here you see this is a single cell, and within the nucleus, the DNA transcribes into RNA. The RNA is processed into mRNA, and it exits the nucleus and goes into the cytoplasm, and gets translated into protein. So I put this into a baking analogy. Let's say your DNA is your grandmother's cookbook. It's a family heirloom. You don't want to ruin it. So you make a copy of one of the recipes in the book. That recipe is a gene in this analogy. And let's say that you're out of eggs and you substitute applesauce. That's kind of the processing, your modern touch to the recipe and gathering all of those ingredients. And then the protein ends up being the final cupcake. So that's kind of what we physically see. And so when there's an error in the DNA, that can lead us to create kind of an inedible cupcake. The DNA is read in these 3-letter words. So if there was a single spelling change, it could change the meaning of the sentence. In this case, they added a B, and so it switched the sentence over completely, made it very unreadable. Here, there was a single A that was deleted, and that also makes the sentence completely unreadable. A large deletion could be a single word, it could be an entire sentence, and we might still be able to make out a little bit of a sentence. The story might still make sense, or the recipe might make sense. And then what's not included in this image is repeat expansion disorders. A repeat expansion disorder you can think of as a word that's repeated over and over again until it runs over the page. And once it runs over the page, that's when it can cause disease. So we call any of these changes pathogenic variants. You may have referred to them as mutations. You might still refer to them as mutations. But I will note that at least in your genetic report, we don't use that term mutation anymore. So we're now adding a descriptor to the type of variant. So pathogenic and likely pathogenic are on the end where we know that this is likely to cause disease. Those would be reported on a genetic report, and an uncertain variant would also be on your genetic report. However, likely benign and benign changes are not likely to be included at all on your genetic report. But we're going to talk about what these uncertain variants mean. So an uncertain variant basically means that this change in the gene isn't seen often enough in the general population. So the lab isn't sure, is this causing the gene to not work, or is it just a unique difference, such as being able to spell color with an O and a U or just an O? It doesn't change the meaning of the word. So if you get something uncertain, it is really important to make sure that you connect with a provider that's familiar with genetics, and they're going to take a lot of factors into account to see how suspicious should we be. Does this actually potentially give us an answer? They'll see, does it match up with your symptoms? does the inheritance pattern make sense with how disease seems to be passing down in the family? Are there any informative relatives that we could test to further explore? An example of an informative relative might be your parents if they're still living, or it could be a much older relative. If we find the variant present in them, we might be able to dismiss it. And then we'll also even look at how close is this change to any known pathogenic variants in the gene. And this is not an all-inclusive list. There's a lot of other things that we'll consider in interpreting these uncertain variants, but it is a lot of work. So it might be worthwhile to meet with a genetic counselor to discuss it further. All right, so inheritance patterns, I alluded to that in the last slide. It's kind of the way that disease passes down in the family. And in this case, we're talking about autosomal dominant inheritance, which is the most common inheritance pattern for ALS. We have 2 copies of most of our genes, and we get 1 copy from our egg contribution, 1 copy from our sperm contribution. And for an autosomal dominant disease, you just need 1 copy to be broken to contribute to disease. That gives kind of a 50-50 chance to pass down the broken copy or the working copy in each pregnancy. So in this scenario, about 50% are affected, 50% are unaffected. Doesn't quite work like that if you actually have 4 children. It's like a flip of the coin in each pregnancy, but it can affect both males and females equally. Autosomal recessive inheritance does exist in some forms of hereditary ALS, and that means that both copies of the gene are broken. So in this scenario, egg contribution has 2 broken copies of the gene. That's all they can pass down to their children. So every child will have one of those broken copies. But sperm contribution, on the other hand, doesn't have any broken copies. And so all of these children, whether male or female, are at least carriers for disease. We used to think that carriers are not at risk of developing the disease, but we're learning that that might not always be the case. And there's going to be an example later on in the presentation that kind of goes over that. And the final inheritance pattern I wanted to bring up, which there's about 1 or 2 genes that can cause ALS that are X-linked. This is on the sex chromosomes rather than the autosomes. The sex chromosomes determine someone's sex. So males typically have an X and a Y, and females have an XX. So XY individuals typically always have very expected and typical signs of disease. Whereas XX individuals have one of those X chromosomes turned off in every single cell. So it depends on whether the broken X copy is expressed or the working X copy is expressed. Where XX individuals, in this case, affected father with X-linked disease will pass down that broken X copy to all daughters, but they pass down their Y chromosome to all sons. And so these daughters, again, kind of moving away from that carrier term, they could show kind of more variable signs of the disease. So that's inheritance patterns. That's kind of all the basics of genetics in a nutshell, but kind of discussing more specifically about the genetics of ALS. I will also be talking about frontotemporal dementia, or FTD. So if we're looking at ALS, about 10% is familial and 90% is sporadic. And likewise, if we test anyone with ALS genetically, about 10% of the time they'll test positive. But what does it mean to have a family history? So the technical definition is at least 2 related family members with ALS or a related condition. This is a pedigree or a family tree. Males are squares, females are circles. These are 4 siblings. This is their mother, this is their father. And likewise, these would be maternal grandparents and paternal grandparents. The blue color is individuals affected with ALS. The orange is a dementia. So in this case, the mother had died at 45 years from childbirth, so something completely unrelated to any neurodegenerative disease. But their grandfather had what they thought was Alzheimer's at 60. Turns out that this was not Alzheimer's disease, this was frontotemporal dementia. And though it looked like it skipped a generation in the family, this relative died too young to live long enough to show signs or symptoms of disease. And talking about FTD in a little bit more detail, we know that it is related to ALS genetically. And so FTD is not like Alzheimer's where memory loss is the presenting symptom, but it can show up behaviorally, can affect executive functioning, can affect language. It's the most common dementia subtype, onset before the age of 60, but it can present much later in life. And some individuals might have both diseases, which is referred to as FTD MND. MND is motor neuron disease, and it's a term that's more commonly used in Europe to mean the same thing as ALS. So what are your chances to test positive if you have familial ALS? That's about 2/3. So this kind of 1/3 of cases, we presume that we might be missing something. If there's at least 2 individuals in the family with ALS and or FTD, especially if those individuals are closely related, like first-degree relatives. Again, if we test anyone with what appears to be sporadic ALS, about 10% will test positive. And those who end up testing positive, we kind of put them back into that familial category. In a lot of cases, we are presuming that someone who tests positive would have inherited that genetic variant from a parent. That's still a little bit uncertain because a lot of times parents are deceased and we don't really have the opportunity to confirm if it's present and if it came from either of them. If someone had both ALS and FTD, even if it appeared to be sporadic, there's again about a 2/3 chance to test positive. So if someone were to test positive, kind of the frequency of these genetic variants, about 1/4 of the time, someone will test positive in C9, which is a repeat expansion. 20% of the time is SOD1, the second most common hereditary cause. Then we have TARD-BP or TDP43, FUS, TBK1, and a bunch of other more rare causes of hereditary ALS. Over 30 genes have been identified, and they explain about 10% of all ALS cases. Most of the time, it's autosomal dominantly inherited. And when an unaffected family member has a mutation or pathogenic variant in one of these genes, it doesn't guarantee they'll develop ALS, but sometimes that risk could be very high. And that is what's known as penetrance. And I will be discussing that in the next slide. It's kind of important to add an analogy when we're talking about penetrance. So these are jars that have kind of a threshold to develop disease, represented by the red dotted line. The yellow circles are genetic components, and the green triangles are environmental components. In this first jar, we have an explanation of multifactorial disease, which is a majority of forms of ALS, where we might have some small genetic factors that together add up with environmental exposures that throw someone over that threshold to develop disease. In this case, we have a highly penetrant single genetic cause of ALS. So there were only a few environmental factors needed to push someone over that threshold. Whereas in this scenario, we have a reduced penetrance single genetic contribution to ALS, where someone had an increased susceptibility to develop ALS compared to this individual. And they need less environmental exposures to put them over that edge. But if they don't have all those environmental exposures, they might never develop disease. In these particular scenarios, we can't put a single cause for their ALS. And that can sometimes be really, really frustrating for families. And then finally, though we talked about the genetics of ALS, I want to show that ALS and FTD are considered to be on a spectrum, and there are some genes that are primarily associated with FTD, MAPTau and progranulin are shown here. And then there's some genes that are only associated with ALS, SOD1 and Valusin protein containing B, or VAP-B. I still really feel like we should consider all of these genes to cause either condition. And so it is unfortunate that we might send off a dementia panel that doesn't include SOD1. We might send off a ALS panel that doesn't include progranulin or MAPTau. All right, so we've talked about all of these genetics. Who are genetic counselors, and what can they offer? What I've already kind of gone over is a lot of education, and that's key in what our skill set is breaking down complex pieces of information into digestible kind of nuggets that are a little bit easier to understand. But we also will take a family history. We'll look into your personal medical record, and we'll provide a risk assessment on how likely it is that you're going to test positive with genetic testing. And we'll also assess what is your perceived risk. What are your motivations for testing? And once we kind of figure those pieces out, we have a discussion on whether genetic testing really makes sense for you in your current life stage. We make sure that you understand what testing can and cannot tell you, and really consider the potential psychosocial implications of testing. We'll talk about what the test procedure looks like, and also alternatives to testing. An alternative might be DNA banking, where you kind of hold your DNA and it's available to yourself or other family members in the far future if you decide later on that you want to proceed with testing. Then we help you come to a decision, and we use a shared decision-making model where we're not just kind of throwing you into the well and making your own decision on whether you sink or swim. but we help you come to a decision based off of what we have now learned about what your motivations are and what's important to you. And then we'll go over the logistics for testing or what to do if we don't proceed with testing today. It's important to note that even if you say no to testing today, you can always change your mind later. Can't do it the other way around. And then finally, with the results, we'll interpret those. Sometimes that takes a long time to do. When we disclose them to you, we'll discuss what the next steps are. And if you do test positive or if there is anything that you need to communicate with family, we'll be here to support you. And let's say you want to meet with a genetic counselor but don't know how. A very simple website, findageneticcounselor.com. You can actually specify that you want to meet with a genetic counselor that specializes in neurogenetics. And you can find ones that will see you within your state, either virtually or in person. But when you do set up that appointment, you'll want to make sure that you understand your family health history, particularly for neurodegenerative disease. And you'll want to gather some of your medical records, some family medical records. And if family members had genetic testing, you'll also want to provide a copy of those results. You don't necessarily need to have your family member's name and date of birth legible on that report. You can redact it if the family members are concerned at all about how the report might be used. Come ahead of time with some questions or concerns that you might have, and consider bringing a care partner with you for both the pre-test counseling and post-test counseling. All right, so you've met with a genetic counselor. Now you've got this report in front of you. If you had your genetic testing done through a neurologist, they might not have taken a great amount of time in explaining those results to you. Know that you can always go directly to the lab that did your testing, or you can go to the institution that you were tested at and request a copy of that report if your provider doesn't already give it to you. And when you have that report in front of you, it's always in a kind of a slightly different order, but these are kind of the key things to pay attention to. The zygosity, classification, the gene name, the DNA change, and the protein change. So I'll provide some examples. In this particular case, we have a heterozygous change, which means only one copy of the SOD1 gene has this change. It is classified as pathogenic, and this is the specific change at the DNA level, which means that at position 112 of the DNA, where most individuals have a G, you instead have a C. And this is the consequence on the protein level, where most individuals at position 38 have a glycine. You instead have that swapped out for an arginine. And because it's pathogenic, going back to that cupcake analogy, let's say it's suggesting that you throw in stones instead of eggs. You're not going to have an edible cake at the end. The second scenario, you have a homozygous change, which means that in the optineurin gene, OPTN, you have the same exact change on both copies of the gene. It is considered to be uncertain, so we're not sure what the consequence is if it's really causing the gene to not work. And it's a deletion of positions 57 through 59. So that's basically 3 letters that are deleted. And what that ends up doing is just, it removes one piece of the protein chain, makes a shorter protein overall. But in this particular case, it might actually not have a true consequence to what that protein is supposed to do. It also could have a consequence. But I'll show you some real pieces of genetic reports so you can kind of get an idea of what this might look like. So in this case, they talk about the gene, the inheritance pattern of the conditions related to the gene, the specific variant, that C dot is at the DNA level, P dot is at protein level, it is heterozygous, and it is uncertain. So it being heterozygous, we care about what the autosomal dominant conditions are. In this particular case, senataxin, or SETX, is an autosomal dominant juvenile onset ALS that tends to be slowly progressive. And in our patient's particular case, they have an adult onset form of ALS that's progressing at a rate that we would expect. So we basically eliminate that as a possibility for explaining their ALS. Example 2, again, an uncertain variant, heterozygous. Here's the C dot and here's the P dot nomenclature. And it's in a gene called TAF15. Now, TAF15 you might not have heard of because it's not really on ALS panels. It's currently determined to have very limited evidence for a true disease gene association with ALS. And most of the time, when we have limited evidence, that ends up later getting kind of determined to not actually be a cause of ALS. But at the time, this was several years ago, our patient had ALS and she had a brother who had a condition that might have been very much like ALS. So we ended up testing her brother and 2 other unaffected brothers for this variant, and it was absent in the brother that had a similar disease. So we again dismissed it as being the explanation of her ALS that appeared to be familial. And our third example here is an optineurin pathogenic variant that is heterozygous. In this case, the particular variant is common in the Ashkenazi Jewish population. The inheritance pattern for this condition is actually semi-dominant. So this autosomal dominant piece here is a little misleading because a specific change in the gene, looking at the C dot and P dot level, it can increase someone's risk to develop ALS if they have one copy, if they're heterozygous. But if they're homozygous for this, they appear to be very likely to develop disease in their lifetime. And so when it's in the dominant inheritance, it increases the susceptibility to develop disease. And this individual basically was 3 times more likely to develop ALS compared to the general population. They were of Ashkenazi Jewish descent. This particular change, if you're of Moroccan Jewish descent, you have about a 13 times greater likelihood to develop ALS compared to general population. So in our patient's case, this genetic variant was just a piece of the puzzle. It gave us a reason that she was at a higher risk to develop disease, but it wasn't the sole cause of her disease. You can think about those penetrance jars where she had the smaller yellow circle that took up about a third of the jar. And then finally, a very obvious answer. We've got a pathogenic variant. It's heterozygous, autosomal dominant inheritance in the FUS gene. FUS has, at least in the literature, been suggested to tend to cause very young onset ALS. But our particular patient didn't have onset until her 60s. and she had no family history of disease because she was adopted. So here's a case of a apparently sporadic case of ALS that ended up testing positive. All right, so when we're talking about ALS genetics, it can be very frustrating and disheartening when people realize, here I am hit with this disease, and now I know that my children or my siblings or my cousins are at risk of developing it also. Here is a little bit of a shining light at the end of the tunnel, where we have our first FDA-approved gene therapy for familial ALS. That particular drug is called Qalsody. Brand name was called tofersen in trial. And Biogen was the one to kind of lead it to the finish line. There were two different trials for this. Valor is complete, but Atlas is continuing. And Valor was basically for symptomatic individuals who had SOD1 ALS. So we confirmed SOD1 was the cause of their disease. This drug did not meet their primary endpoint. They showed it does slow progression of ALS when you look at the ALS functional rating scale, which kind of determines degree of disability from ALS, but it didn't reach significance. However, because they met secondary endpoints where they showed it decreases the level of SOD1 protein in the cerebrospinal fluid, it decreases neurofilament light in plasma, which is a sign of neuron death. And so it suggested it was effective, and FDA approved it on an expedited rate. But it still does need to show clinical efficacy. Those in the audience might know about Relyvrio. That also got an expedited FDA approval, but they later did find out during open label studies that it was not clinically meaningful, and the company decided to withdraw the drug from market. So that is still a possibility to happen with Qalsody if they don't end up finding that statistical significance. It's important to note that about 7% of patients in these follow-up studies have had significant adverse events that appear to be related to the drug. And so it's very important when you're considering this therapy, if you're eligible for it, to have an in-depth discussion with your doctor about whether the risks and benefits are worthwhile to start the drug. Atlas, on the other hand, is for people with preclinical SOD1 ALS. So this would be kind of unaffected family members that have a genetic risk to develop ALS because of the SOD1 gene. But they specifically have to have a highly penetrant variant in the gene that is associated with faster progression. When these individuals have an increase in their neurofilament light levels, they get started on Qalsody so that they can see, the earlier we initiate therapy, it does seem to have a greater efficacy. So can we slow the onset of disease? Can we postpone the onset of disease? And this next slide kind of goes into those fast progressing variants. So the dark purple are genetic variants in SOD1 that are considered to be fast progressing. So if you don't have a variant on this list, then you might need to show that there's a family member who died within a year who had the SOD1 variant. You might need to show that a lot of the individuals who had the variant ended up developing ALS. And so that's important to keep in mind, that though there's a trial right now available for people who don't yet have signs of ALS, the particular variant in your family might not still be eligible for that ATLAS trial. And finally, what are the chances to have a pathogenic variant in SOD1? We kind of did go over this, but about 20% of the time, if you have a familial form of ALS, you'll test positive in the gene. But if you have a sporadic case, only about 3% of the time will you test positive. So it's still a small number of patients that are eligible for this treatment. Let's say you don't have SOD1 in your family. Let's say it's CHCHD10. This is a super rare cause of ALS. There is actually a foundation that might be able to create a research treatment to test out on you. So the NLORM Foundation basically pays for creating the drug, and they pay for the drug itself, but they do not pay for the cost of administration of the drug. And these drugs tend to need to be delivered via the cerebrospinal fluid, and it might be considered to be an inpatient visit or a intensive outpatient visit. So in order to be considered for this, you have to live in the United States. You have to have a nano-rare form of genetic ALS. So 1 to 30 patients worldwide have this specific change in this gene. So if you have C9 or SOD1, you would be ineligible for this because of how common they are. But you have to have had genetic testing, you have to have a full diagnosis, and the effect of the variant on protein function needs to be understood. There needs to be a research physician who agrees to partner with you, and they have to be housed at an institution that can support your research, or support the research. And so there's a lot of logistics there, and I think the biggest issue is cost. But it is something to kind of check out if you do have a super rare form of genetic ALS, and the website is nlorum.org. All right, so hopefully you guys have learned something new this evening. My email is up above, tara.jones@cshs.org. I'm more than happy to connect with you if you have any questions, or any family members that live in California that want to speak with a genetic counselor. And I'm open for questions.
Thank you so much, Tara, for this wonderful presentation. I was even able to follow. Thank you for simplifying it.
Good.
So there was one question, if I understood it correctly. It's great news about Qalsody. Will entities such as Rush, ALS Chicago consider or reconsider utilizing the prescription? We are doing well with just riluzole, but interested now in Qalsody. You have, my answer was you have to have tested positive for SOD1 to qualify. Correct?
Right. That is true. So you're only eligible if you have SOD1 as your cause of ALS. So you have to have had genetic testing to confirm that. And I'm not sure if Rush is already treating patients at their institution for that.
Yes. I did answer that. So they are offering it. They have to be followed there, or at least have a visit with the doctor to qualify.
Gotcha. Okay.
Yeah. I do have also a couple of questions that came through before. One of the question was, we had somebody inquire about whether there are gene to test PLS.
Yeah, so with PLS, essentially, if we have a patient that has had PLS for over 3 years and it hasn't turned into ALS, we don't fully understand the genetics of PLS. It's like a rare condition on top of a rare condition. Um, but what I'll usually do is we'll do a really comprehensive test called exome sequencing, and we'll also include the C9 repeat expansion. And sometimes we learn that PLS is actually a different hereditary disease, but the chance to find something with that testing is really low, like maybe a 3 to 7% chance.
Thank you. I do have a couple more questions. One of them is like a double, two questions in one. So how do environmental factors interact with the genetic predisposition in ALS? And also, can lifestyle changes influence the expression of ALS-related genes?
That's a good question. I'm not super familiar with all of the research being done to look at environmental factors for ALS, but it's starting to look a lot like what we think about with cancer, where um, people have like a threshold to develop disease, and certain factors might get them closer to that threshold. Um, we know that head trauma is a big risk factor for neurodegenerative disease in general. Um, when we're looking at some of these highly penetrant hereditary causes of ALS, such as some SOD1 variants, um, right now we don't fully know if there's anything that can really be done to decrease someone's risk. But generally speaking, leading a healthy lifestyle is probably going to still have a lot of benefits. So moderate exercise, eating healthy, staying social, learning new things, getting enough sleep can all still hopefully change the presentation of the disease at least.
Thank you so much. Another question is, how should individuals with a non-related genetic mutation approach family planning?
Good question. We didn't cover it in this presentation, but the way the way I present it to families is if we know the genetic cause of ALS in the family, then we might be able to prevent it from passing down to future generations. It's important to think about the cost of trying to do that, about the psychological drawbacks of going through the IVF cycle of harvesting eggs, for example, and attempting a pregnancy that might still fail after all of those efforts. And so even though it's available, it's not easy to go through. And we have to consider with the way that research is moving forward, by the time someone's future child is old enough for it to matter, there might actually be a treatment or a cure. And so there's a lot that people need to weigh in on that decision on whether they do try to prevent it from passing down.
Thank you. Last question that I have, and then we can wrap up. What are the ethical considerations involved with genetic testing for ALS?
Another topic that I didn't cover in this talk. So when someone has a clinical diagnosis of ALS, I always say disease trumps genetics. When we're talking about people who are asymptomatic, who just want to get tested because they have a family member who had ALS, or there's a known genetic variant that they're testing for, there is a theoretical possibility of genetic discrimination. And that essentially means your genetic makeup could prevent your ability to access certain services, or you won't have an equal access to those services. You might have to pay more for getting into a concert or something. I'm bringing it to all the extremes, but when we think about genetic discrimination, we really think about life insurance, long-term care insurance, disability insurance. And so it's important that you consider if those insurances are important to you, and to try to get policies for that before you seek genetic counseling and testing. And it's also important to be truthful with what you know, because if you were to rely on an application and that were to be documented in your medical record, by the time you pay your premium for decades and you decide to take out a claim, it might end up getting denied. And so it's really a delicate balance. But someone with ALS who tests positive for genetic testing, that alone shouldn't prevent their family members from being able to have access to those insurances.
Okay, well, thank you so much. I don't see any other questions on the list, so we're ready to wrap up. We hope that you found tonight's program insightful. I sure did. A heartfelt thank you goes out to our exceptional speaker for dedicating time tonight to share her expertise and knowledge with us. We extend our gratitude to all of you as well for joining in. As we prepare to log off, a friendly reminder that you can anticipate receiving the recording of tonight's program via email. If there are any lingering questions that you can think of afterwards that remained unanswered during that you think of afterwards, please don't hesitate to reach out to us. We are committed to addressing your inquiries as promptly as possible. Wishing you all a good night, and please take care. Thank you.